Hello, everybody. This is Mrs. Wild from your WCA Earth Science class. And today I'm going to show you how to do the um, portfolio on half-life or geologic time. So this is the one that we are going to be working on in your Earth Science class. It's an alternative to the Geologic Age Lab. It helps us to understand how to use radioactive decay to determine the absolute age of artifacts and fossils. So it first talks about kind of what radioactive decay is, and we are going to be using two specific radioactive elements or isotopes, carbon-14 and uranium-238. Carbon-14 is a radioactive isotope that is found in living things, but it does completely change over into nitrogen-14 in about 50,000 years. So that means that if the fossil is older than 50,000 years, that you can't use carbon-14 to determine its age. You have to use a different isotope. Uranium-238, on the other hand, changes over into lead-206, and the half-life for that is it's over 4 billion years. So we can use that for pretty much anything that's inorganic found on Earth. So we're going to be using the website PhET. We are going to be looking at a specific couple of simulations. The first simulation is called the half-life simulation. It's under the tab that says half-life here. And for this part of the simulation, we are going to determine the number of atoms decayed before the half-life line. If we start with 10, 20, 30, 40, and 50 atoms. So let me just kind of show you what I mean. So we're going to start off with just carbon-14 as our element. So that's selected on the right. And then what I want to do is I'm going to hit the pause button to start, and I'm going to add 10 carbon-14 atoms to the mix. Then I'm going to push the play button, and I'm going to pause it when it gets to the half-life line right here. So we start off with 10 of them. And we pause. And you have to be kind of fast, but we did pause prior to the line. And we have at this point 7 nitrogen-14 and 3 carbon. And you might want to reset it and do it a couple of times and kind of take the average. So I'm going to do that again. I'm going to pause it. I'm going to add my 10. I'm going to push play. And this time I ended up with 6 and 1, 2, 3, actually 5 and 5. So we have ended up with 7 nitrogens. Now we're at 5. That's an average of 6. And let's do it one more time. Oops. This time I didn't pause it, but we're okay. Actually, let me just do that one over. I think I screwed that one up. So yeah. So let's pause it to start. Add our 10. All right, now I'll push play. All right, so now we have 1, 2, 3, 4, 5, 6. So our 3 numbers were 5, 6, and 7. That gives us an average of 6. So I'm going to go here under my copy, and I'm going to say we ended up with 4 carbon-14, and 6 of them had changed into nitrogen. And you're going to repeat this for starting with 20 atoms. So you can always pause before you start. Last time we're going 20 atoms. And we're going to press the play button. And we're going to pause it. We're going to count the number of carbons, count the number of nitrogens. If you really don't want to count, just look up here. We've got 11 and 9. And do that a couple or 3 times so that you can get an average. And that average number is what goes here. Okay? So you're going to fill in this data table. And then you're going to answer some questions that go along with it. Questions 2 and questions 3. Question 2 says, what percentage or fraction of atoms are expected to decay before the half-life is over? And question 3 says, why is the number not always perfect? Now you're going to choose custom and move the half-life bar on the chart. So let's do that. We're going to reset everything. We're going to select custom. And it says here, Move the half-life bar on the chart and choose a decay time frame. So I'm just going to make one up. I'm going to go with right there at 2. Okay. And then, oopsies, what is true no matter what time you choose? So if I have to start here, I have to add some, and I'm going to keep doing it, right? Oops, I have to start with 10. So we're still at 4 and 6. So you can kind of play with that. You can check different custom ones and see, is the ratio pretty much always the same? That's kind of what you're looking at for. Now you're going to go to the next tab, the decay rates tab. Decay rates, that's this one. And it says, click on the bar on the bucket and drag it to the right to add atoms. Add several different amounts and watch where the half-life on the graph is, where the blue and red lines cross. Okay, so we are going to see this little thing. We're going to add atoms. Okay. Notice it's right around 5,000. Let's reset it all. Let's try it again. Still right around 5,000. Let's try it again. Still right around 5,000. Okay, so you're going to keep experimenting with the number of atoms you start with. Does it make a difference as to where the two lines cross? That's the question you're asking yourself. Then we're going to go to on the measurements tab and we are going to plant a tree. So let's go back here. Measurement tab. We need to plant a tree. And what you want to do here, it says, what happens to the amount of C14 when the tree dies? Let's start that over, okay? Start planting the tree. Watch C14. Notice C14 is checked on here. Notice it's at 100%. Tree is dying. What's happening to the amount of C14? And then if I found a piece of preserved wood and if 65% of the atoms were C14, how old would the wood be? So to do this, I want to pause it when it gets to 65%. So we're going to keep letting it run and pause it when it gets to 65%. And then it's going to tell me the age right below. Okay. And we can go ahead and reset everything there as well. And now we're going to click on the rock and we're going to use the C14 line again. And the question is, when I click on rock and I erupt the volcano, why is there no line forming under C14? There's nothing. There's 0% carbon 14. Time is a ticking. I can cool the rock, still nothing. Think to yourself, why would there be nothing with the rock? So let's change it. If 0.0% comes up in the black box, what does that mean? And just to kind of give you an idea, if I switch this to uranium and I do the same thing, I have 100% uranium. Once the rock cools, notice the amount of uranium. Oops, sorry about that. But once the rock cools, notice what happens to the amount of uranium. It's a slow line that's forming here, but now we can kind of see that that is dipping. Okay, and our last section is using different items in our dating game section. So in the dating game section, what you're supposed to do is use this little probe to measure the ages of the fossils in each group. And you kind of want to come up with an average age here. So to do it, you have to select the element that you need to test. If it is an organic item, so it was once living and it's less than 50,000 years old, you can use carbon-14, and it should measure the amount of carbon-14 left in that item. See, we can see this guy's got 83.9%. To get to the age, what I want to do is I want to drag this double-headed arrow so that the percentage up here matches the percentage in the box. So I'm going to drag it to the left. I want to get my percentage to match, or at least come close, right? So it tells me the age here is 1,483 years. If I put it in here and I check, that gives me the age. Okay. If the item is older and it is organic, like I go down way down to this trilobite, for example, it's not going to work because it's too old to use carbon-14. So you have to use a custom measure. And you're going to have to change the age here. I'm changing it to 100 million. You have to make sure it's right on there. There we go. 11.4%. Again, drag the double-headed arrow till you match the percentage. And it says 312 million years. So that's 1, 2, 3, 4, 5, 6. Don't forget your zeros, okay? If it's a rock and it's not a fossil, you'll have to use the uranium-238 for the rock, okay? And again, you drag that double-headed arrow. Once you have the ages, you're going to average them together, so add them all up and divide by however many there are, and you write it into the box here, and that's worth 5 points. And that is all you need to do for this portfolio. So if you have any questions, anything you don't understand, let me know. But otherwise, I will see you in the next video. Bye.